All right, everybody, welcome back to the KSR YouTube channel. Today, back to thrashing on SoccerMom. Get her ready for sick week. See, Sean's car is almost ready to have the nose put back on it, but I've got to go remake a radiator hose on it because we're converting it to a mechanical fuel pump for the race system, which we'll show you later. But Will's putting the fish rods in. I am working on valve covers, which you'll see here in a little bit, because we are going to be upsizing the hose that goes from the valve covers over to our tanks, the catch tanks, and we are also fabricating some new catch tanks that are going to mount probably somewhere over here down in the fenders. Lots of little stuff to figure out today because we want to go test next weekend before sick week. We also have to get our trailer mounted, get our seats mounted, get the drive shaft loop done, get the floor patched, get the floor painted, get the cage painted. We got a lot to do. So, show them the list, or I don't know where the list is.
It's on the phone. It's on your phone.
Oh, that's right, it's on my phone. But yeah, we got a list, and we're going to start checking things off so that we can go to the racetrack. One big thing we've got to figure out still is we've got to figure out how to make this thing run on pump gas with these huge injectors. Now, it may be that we just swap injectors before we hit the street, but we're going to figure that out. So let's get to work, take you guys along for the ride. All right, so one of the things we're doing today, like I mentioned before the intro, we're actually modifying our valve covers to put a 16 AN bung on them to run over to our breather tanks. Well, our coil brackets are for stock valve covers. Our plug wires are for stock valve covers. We don't have any fancy schmancy valve covers. So we're gonna be modifying our stock covers. So the first thing I'm doing, taking the plug out here, we are going to just weld that up. And took the, actually this side didn't have a baffle. Well, it did, but we're plugging that anyway. And then I'm gonna take this, I'm gonna cut this down so that it adds, you know, I'd be able to put this at a little bit of an angle so it's kind of straight up and down more so. So then we'll have a nice fill cap. And then we'll put a 16 AN bung on the side of it that'll run back around to our breather tank. And the other side is gonna be a little more involved because I gotta figure out how to put a tube on it, preferably not at the back of the valve cover. So we've taken the baffles out of the inside because the holes that are in the baffles are smaller than the ID of our 16 AN bung and hose. So we need something bigger, right? Otherwise the valve cover is still the restriction, which is kind of one of the things we think we found out on mullet. We may put some of the baffling back in mullet at some point since they're both at the back of the valve cover. Anyway, we're not working on mullet today, we're working on SoccerMom. So either gonna have to do something maybe with some kind of internal baffle, but we'll figure that out as we go. So get back to it. See you guys in a little bit. All right, everybody. Well, talk over time lapse again here in this video, and I'm actually trying a new microphone. So you guys let me know if you think it sounds better, worse. Yeah, hopefully it sounds better than it used to. But you can see we're continuing with our project of adding the fittings to the valve covers so that we can hook 16 AN hoses up to the valve covers instead of the 8 that we used to have. And we think that was probably a big reason for our crankcase pressure that we were noticing once we switched to alcohol. Kind of just like mullet, noticed a lot more crankcase pressure after the switch to alcohol. When we were on E85, no problems at all. Switched to alcohol, motor's still fine, everything checks good. Not so great on the crankcase pressure. So here in the video, I'm doing a little bit of calculation to see if I actually need to remove the baffle like I had talked about earlier in the video. And the way it worked out, I just could drill some extra holes in the baffle and actually have more open area than what we have
on the inside of the 16AN fittings and hose. So that kind of worked out well. Just doing a little machining to clean up the ends of the pipe, make everything square, and the bung there to true it up so that when I weld everything to the end of the pipe, everything's nice and true. And one thing to really make sure of when I'm doing any welding on any part that is going to see the inside of the engine, I take a ton of extra time, which you'll see here in a little bit, to go through and deburr the edges of the holes, clean out the inside of the pipes, because I do not want any debris, even as minute as like aluminum dust, to have a chance to stay inside of the engine and possibly get down into the oil. And then if it gets down into the oil, it stands a chance of getting sucked into your oil pump, possibly damaging the oil pump because the clearances are extremely tight inside of your oil pump. So we're trying to avoid all that. So I spend a lot of extra time cleaning out the inside of the baffles, cleaning out the inside of the valve covers. And you can see now I'm welding the bungs on, and I kind of put myself in a tight spot with welding these particular bungs and pipe on. Other stock valve covers I've worked on, I haven't used quite as large of a pipe. And on this one, the edge of the pipe got really close to one of the bosses for the coil mounts. And it was a little bit tough to weld. So got all that taken care of. And I'll also be kind of honest with you guys that this valve cover gave me a fight when I started welding on it. You know, they're cast valve covers, and some of them apparently are cast a little bit nicer than other valve covers. And the black one that I cleaned the paint off of, that one welded really nice. This one, not so much. I had to spend some time going over the weld pool, kind of baking it and swirling the puddle around so that it would kind of open up and burn out the porosity. These are done. Let's get back to the rest of the video.
All right, well, we're up in the air. I'll show you why in a second. But for now, the valve covers are on. Both sides. I think I'm showing the right thing right there. Is there a valve cover in the picture? Yeah, I see the intake manifold. So, yeah, we got our valve covers decked out with 16AN fittings, and then the driver's side has a nice filler cap on it. Poly O-ring sealed filler cap. And you saw the hose end on there that we're going to use to start building over to our catch tank that's going to be down here in the fender. And right now Will's standing on the drive shaft loop because we still have to do a drive shaft loop. Will got the floor panels for our big holes welded in. The reason we cut that out is the old bars went through there, and also a lot of this area was kind of spotty with rust. So we decided to cut it out plenty big enough so that we can work through there to get the new bars welded in, get the subframe connectors welded in, put a little seam sealer on it to seal everything up nice. And our drive shaft loop, let me show them where the drive shaft loop's gonna go. Drive shaft loop is gonna tuck right here, and we'll weld it to the floor a little bit, but we'll also run a bar from here over to the subframe connectors there, which will help just tie the middle of the car together even better, and the floor. This little weld mark right here is actually the base mount for the shifter. Kind of gives you an idea where the shifter is in the car. But once we do that, we're actually going to lower this thing down and crank up the new engine. Kind of go over what's going on with that engine, what's different about it, what's the same. But yeah, let's get to work welding this drive shaft loop in. Talk to you guys in a second.
All right, well, this time lapse is going to be welding in the drive shaft loop. And you can see I'm kind of grinding on the subframe a little bit so that I can angle the bar forward that's going to connect the drive shaft loop out to the subframe. And what I'm trying to accomplish here is I want this bar to land on the new subframe connector, bridge across the end of the factory subframe, and still contact the drive shaft loop while the drive shaft loop is in the location that I want it to end up in. Sometimes you got to use a hammer. You might have just seen that. Had to move the floor just a little bit to get the drive shaft loop centered. And we're going to go ahead and tack that, take it over to the bench, fully weld it. And then once we get that done, we'll bring it back over, do the other side bar. Got to do some grinding on it also so that the bar connects to the subframe connector and the factory subframe. And I did that just so that kind of the way I think the more stuff I can tie together, the better the end package is going to be. It's going to end up being stiffer to tie things more together. With drive shaft loops, I really like tying them in as best as I can. Some cars we put a tunnel in that's kind of like a heavy sheet metal tunnel, sometimes titanium. So if the drive shaft does ever have any kind of failure, the goal is to keep it inside of the drive shaft loop or the tunnel. With a car with a factory steel floor pan, typically they're pretty safe unless you've got a floor pan, you know, that is extremely rotted out. SoccerMom's drive shaft tunnel and transmission tunnel is in good shape. Some of the floor pans weren't in the greatest shape, but now that we've cut out the area at the back of the passenger side and the driver's side footwell areas, we feel like we've got pretty solid floors in the car now. So I'm welding everything in right now on the drive shaft loop to the tunnel. There's like a kind of thicker material for a cross brace there, so it made for a really nice tie-in for the drive shaft loop. It's going to make the floor super sturdy. And yeah, I kind of went a little overboard on how much I welded to it right there, but it's going to be nice and strong. Tie everything together super nice. Should be good and solid for us. And next part of this video, we're going to be getting SoccerMom's new engine cranked up. So stay tuned. Here we go.
All right, well, drive shaft loop is completely in and done. And you might have seen in the time lapse, yeah, I went a little overboard on the welding. It's welded all the way around to the floor. TIG welded there. Nice and solid. And compared to the old flat, oh geez, I got something in my eye. Compared to the old flat steel, 1/4 inch thick, 2 inch wide crossmember or drive shaft loop, this is 4.5 pounds lighter. So that's cool. We get back a little bit of the weight that we put into the funny car cage. The subframe connectors, I didn't weigh the old ones completely because we had cut them out in some different pieces and some of them got thrown away. But between the harness bar, the pieces that I had left of the subframe connector, the old drive shaft loop, the old transmission crossmember, we had 50 pounds of total weight there. Hopefully it's not too much more than what we took out. We are putting the lighter seats in it, and eventually the passenger seat and the mount will come out. So we won't have too much to do there. It'll just be the driver's side seat, which we've got to go down, fabricate mounts for that. Don't think we're gonna get to that today, but we are gonna lower this thing down, put the coils on it, fire it up, so we can hear what the new motor's all about. And then from there, it's probably gonna wrap up the video for today. So, can't really go drive it. We could, but I don't wanna sit on the floor. So let's get this thing down, throw the coils on it, and see if we can fire it back up. All right, the time has come. Will's over there, nervous. Nervous?
A little bit.
So we did spin it over just to prime the oil system, move a little fuel up into the regulator. But we have not tried to crank the new engine yet. And this is basically our old rotating assembly in a new Gen 4 aluminum block instead of the old Gen 3 aluminum block that we kept having problems holding the head gaskets down on number 8. So I got my laptop set up for a data log. And that's ready to go. Battery says 16.3. Good. So let's take it right apart. Oh, is there a drive shaft in it? Okay, so it's not going to try running through the. Oh yeah, drive shaft's over there.
Other yoke in the rear too, the
Okay.
dummy yoke. So that all should be fine. Oh, you know what though? Transmission lines ain't hooked up to nothing.
Oh, dang it. Pause for station identification. All right. Now that we have installed a union in our transmission lines, we won't make a giant mess underneath the car. That was a good catch, Will, because we about had a big mess on our hands. And fingers crossed, let's...
You want me to start from out here?
Yeah, let's see if it starts. I got it, yeah. Cranking right up, yeah! That's exciting. They cranked. I'm gonna crack the door. Leaking out of the back of the tail shaft seal. Oh yeah, push the yoke out. All right, well that's pretty good first crank up. Look at some data and get back to this in just a minute. All right, well, the data log looked great. Pretty excited about all that. We've got more oil pressure than we used to have. So we're trying a new oil pump in this engine. And with it being dead cold, seeing, 80 pounds of oil pressure at idle, that doesn't really alarm me at all. Be curious to see what it makes, wound out to 8,900 RPM, which hopefully, once we get our new gear components, which should be here Monday, we will be assembling a new third member for this thing with a 350 rear gear instead of the 410 that we have now. That should get us through the quarter. Should also help out driving on the street. But anyways, that's gonna wrap up this video. Pretty exciting we got it cranked. Actually very exciting we got it cranked. Makes good oil pressure. The first crank up, how about that? First, we don't have that not cranking on the first start thing like some other Florida YouTuber shops. We got ours to start. First time we hit the key. Yeah. All right. Thanks for watching. See you guys next time.